Hi friends, good evening everyone. This is Manjunath Sir, CSAT faculty member in IASBABA. You all have attended CSAT yesterday, 28th May 2023, and the general opinion is CSAT was too tough. Now I am here to make the things simple, and I will tell you in this video how to approach if the question paper is of this level, is of this type. Okay, now let us solve problems. The first one I have picked: each digit of a 9-digit number is 1. It is multiplied by itself. What is the sum of the digits of the resulting number? Your options are 64, 80, 81, 100. See, we are concerned with only a 9-digit number, and it consists of only ones. Okay, each digit of 9-digit number is 1. It is multiplied by itself, meaning we want its square. Okay, now let me first give you the basics related to this problem. 1 square, double 1 square, triple 1 square. How to find out the squares of numbers involving only ones, like this. Okay, how to find out the square of a number involving only ones? 1 ones are 1, 11 11s are 121. We all know this. Now with the same ease, how to manage the rest? See, here there are 3 ones. Go till 3, 1, 2, 3, then come back to 1. Here we have got 4 ones, so go till 4, 1, 2, 3, 4, then come back 3, 2, 1. This is how we can manage the squares of numbers involving only ones. Okay, now in the problem it is a 9-digit number, meaning we want the square of a number, 9-digit number, with only 1 as its digits. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. We want its square. Okay, that is first part. Second part is you will have to add all the digits in the resulting number, right? So we have got 9 ones here. Start with 1, go till 9, and then come back. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now come back. 8, 7, 6, 5, 4, 3, 2, 1. This is the resulting number that we will get. Okay, and we don't want just the resulting number, we want the sum of the digits of this resulting number. We want the sum of all these digits. Okay, how to add all these digits? To add also there is a trick. 1 to 8, and the same part is repeated on that side also. So if you can manage to add all these, the same thing is there on that side. So this twice. Okay, this is once, this is twice, and once you do both, then you can add 9. Okay, you will have to add 9 also to the sums of both these sets. Okay, now I will tell you how to add the numbers from 1 to 8. Okay, you can do it manually. You can easily add all these manually. Okay, that requires bit practice. You will have to practice to add the numbers. Okay, So 1, 2, 3, 4, 5, 6, 7, 8. How to add? Use this formula. N plus 1 by 2. This is the formula to be used. So we are adding here from 1 to 8. So n will take 8. 8 plus 1, that is 9 by 2. 2 ones are 2 fours are 4 nines are 36. What do you mean by this? First 8 36, last 8 also 36, because the same set is repeated there. And other than these two sets, we have got 9 as well. So 36, 36, 72. To this 72, you will have to add this 9. 72 plus 9 gives us 81, which is there in the third option, right? So the third option is correct answer. Okay. So there are two parts here. Part number 1, you will have to know this trick, how to find squares of numbers involving only ones. And then the second part is how to add these digits. Okay. This is the formula to find out the sum of the first n natural numbers. 1, 2, 3, 4, up to any number you can add using the formula n plus 1 by 2. Okay. And we have got formula for even to add squares, 1 square, 2 square, 3 square, 4 square. You have got even formula to add the cubes of the first n natural numbers as well. Okay. You have got formula even to add even numbers, odd numbers also. Okay. Now how to find squares of numbers involving only 9s? Let me tell you this also. And one more important thing, earlier we had 9 ones and we found its square. Okay. But if you use calculator to find the square of a number involving 9 ones, okay, you cannot manage. Okay. So the earlier trick will definitely beat the calculators. Even if the calculators are allowed, you will be helpless in the examination hall. That's the point. Okay. Here the earlier trick has beaten the calculators, and this trick will beat even the computers. How to find the squares of numbers involving only 9s? 9 9s are 81. Don't forget this, 9 9s are 81. If you could remember this 9 9s 81, then you can easily manage the rest. 81, in this 81 we have got two digits 8 and 1, and they will remain fixed throughout. Now let's see the other changes that take place. Here we have got 2 9s, less 1, only 1 9, only 1 9, only 1 0, 8 and 1 are always fixed. Here we have got 3 9s, less 1, 2 9s, 2 zeros, 8 and 1, they are always fixed. Here we have got 4 9s, less 1, 3 9s, 3 9s, 3 zeros, 8 and 1 are always fixed. And bit related to this, okay, one problem is asked in the same CSAT involving only 9s. Okay, 9 times he is writing 9s. Okay, we will be solving that problem as well here. Now you write any number of 9s and within no time we can find its square. Here we have got 6 9s, less 1, 5 9s, 5 zeros, 8 and 1, they are always fixed. And you can apply this trick even for the first case. Even in the first case you can use the same trick. How many 9s are there? 1 9? Forget it. No 9s, no 0s, but 8 and 1 are always fixed. Okay, this is everything about this problem. Moving on to the next one. This is the problem on missing numbers. You can say here this particular sign, okay, is used to say some particular operation. Okay, so which operation? It can stand for multiplication, it can stand for both addition and multiplication also. Okay, so what is done, he has not disclosed. Whether he has added the digits or multiplied or what, he has not disclosed, and that you will have to check. Okay, so 7, 9, 10, all these things have given us 8. Okay, 7, 9, 10, all these together have become 8. Let me add all these. 7 plus 9, 16. 16, 17 plus 0, total 17. 1 plus 7 is 8. Okay. So just add all the digits to get the final answer. Here you can check this one: 23, 4, 15. We want this. So just add all these. Just add all the digits. 5, 6, 10, 13 plus 2, 15. Again add these two to get the first option, 6. Okay, the very first option, 6, is correct answer here. The trick, the logic used here is just he has added all the digits, right? Just add all the digits and you will get the final answer. Okay, that is the trick here. Just add all the digits to get the final answer, right? This is literally a simple problem, in fact. Now moving on to the next one. This is a problem on coding and decoding, and according to me this is the simplest problem in this question paper. 0 to player. Okay, 0 is coded as CHUR. Now you will have to start studying how we can get CHUR from 0. Z has become C. Z has become C. He has dropped A, he has dropped B, and he has written C. After Z, A will come, and then B will come, then C will come. Meaning he has jumped 2 in between, 2 alphabets in between. After E, he has jumped F, and G, he has written H. After R, he has jumped S, he has jumped T, he has written U. After O, he has skipped P and Q and written R. Meaning in between, you will have to skip 2 alphabets in between. Okay, that is the only logic, and the logic is also very, very simple here. PLAYER, player. We will have to code this word using the same logic. P Q R, you will have to write S. L M N, you will have to write O. After A it is BC, you will have to write D. After Y it is ZA. drop ZA, skip ZA and write B. After E, you will have to skip F and G. You will have to write H, R, ST, U, SOD, BHU, SOD, BHU. It is there in the last option and that should be marked. This is, I think, the easiest problem in this whole question paper. Out of 80 questions, this is the simplest. Okay. Moving on to the next one. Choose the group. Choose the group which is different from the others. Odd man out. Okay. 3 groups are same and only one is different. And for this, my dear friends, you will have to have knowledge about prime numbers. Prime numbers. If you observe keenly all these numbers, they are all prime numbers. And you are supposed to know each and every detail about prime numbers. Okay. Prime numbers, they are called unbreakable numbers. Unbreakable numbers. Opposite word, composite numbers. Prime, opposite, composite. Breakable, unbreakable. What else? One is neither prime nor composite. One is neither prime nor composite because it has got 2 equal factors. 2 is the only even prime natural number. And one more important thing, friends, you check previous year question papers, especially 22, 21 and all. You will get to see at least one question on prime numbers. And we have got one more problem in the same question paper on prime numbers. That is the reason why I said you are supposed to know each and every detail about prime numbers. 2 is the only even prime natural number and the rest of them are all odd. What else? They are divisible by only 1 and itself. They are divisible by only 1 and itself. Okay, prime numbers are divisible by only 1 and itself. So prime numbers start with 2, 2, 3, 5, 7. This is how they go. 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So all these are prime numbers in the first 50 natural numbers. So there are 15 prime numbers in the first 50 natural numbers. So this is how we can easily remember 50, 15, right? 15 plus 10 is equal to 25. 15 prime numbers from 1 to 50. 10 prime numbers from 51 to 100. Okay, in the second half. So total how many are there? 1 to 100, 25 prime numbers are there. And how to check? How do you check? You take any prime and divide it by 6. You divide any prime number and divide it by 6. Your remainder will be either plus 1 or minus 1. I will give one simple example here. 17 is prime. Divide 17 by 6. 6 3s are 18 minus 1. So you will be left out with either plus 1 or minus 1 as the remainder whenever you divide a prime number by 6. Right? So 91. 6 ones are 6, 6 fives are 30. Okay, but 91 is not prime number. Okay, 91 is not a prime number. 91 is composite number because 13 sevens are 91, right? 13 sevens are 91. This is composite number. That is the reason I said this is not the method to check whether the given number is prime or not. Here what I said was, you take any prime number. Okay, you take any prime number, divide it by 6, and the remainder will be +1 or -1. That I said. I didn't say that if you divide a number by 6 and the remainder is +1 or -1, then it is prime. No. Okay, it is on from that side, meaning first it should be a prime number, then divide it by 6, then your remainder will be +1 or -1. Okay, so all these are prime numbers, all these are prime numbers, all these are prime numbers, but only in the last option 91 is 13 sevens are 91, right? It is composite number, therefore the final answer will be the last option. In all the groups we have got prime numbers except the last one, and I have been telling you most important tables, and here it is proved 13 sevens are 91. If you don't know that, you cannot manage this, right? Because almost all the numbers are looking prime only here. He has put only one composite number in the last option. Okay, and only when you by heart all these tables, only then you can manage, okay, easily. This is everything about this problem. This is purely based on prime numbers and tables of 13. Moving on to the next one. P, Q, R and S are distinct single digit positive numbers. Then what is the greatest value of P plus Q into R plus S? Your options are 230, 225, 224, 221. See, he is talking about the greatest. When he uses the word greatest, then quickly he will have to go with these digits and not 1, 2, 3, 4. If you take 1, 2, 3, 4 and all, then you will be getting the least. But he has used the word greatest. That is the reason why you will have to take quickly the digits of this order, higher order. Okay. Digits meaning below 10. From 10 onwards you can use the word numbers, not digits. Okay, so the digits are 1 to 9 and higher version is 9876, higher part. So P, Q, R and S, one will become P, one will become Q, one will become R, one will become S. This is one thing. Now P plus Q and R plus S. So here it is better you make these two as P and Q. 8 plus 7, 15. 9 plus 6, again 15. So this is 225 and that is the largest. See, you will have to go for combinations, okay, in such a way that the difference between them should be the least. The difference between the sum should be the least, only then you can expect the greatest product. Okay. So here, if you go for other combinations, 9 plus say 8, 9 plus 8 is 17. 7 plus 6 is 7 plus 6 is 13. This will become 221. Why? Because there is more gap between the numbers. Here the least gap, therefore the greatest. Here the gap is higher than this, that is why you are getting lesser product, right? So the final answer is 225 because these are the closest numbers. You cannot expect this gap still to reduce. Okay, this is the least, the gap is 0 here, therefore this will be giving you the greatest product, right? So this is everything about this problem. Moving on to the next one. For any choices of values of x, y and z, the 6-digit number of the form xyz is divisible by, your options are 7 and 11 only, 11 and 13 only, 7 and 13 only, 7, 11 and 13. This question is straight from my class. Okay, within no time you should be able to mark the correct answer. See here, it is not just 7, 11 and 13, it is for 1001 also. Okay, how to check the divisibility of number by these 7, 11, 13 and 1001. If I say 1331, start from the right hand side, make a group of 3 digits, start from the right hand side. From the right hand side, a group of 3 digits, 331. So one part is 331, the other part is 1. The difference is how much? This is divisible by 11. Therefore, this number is divisible by 11. Make a group of 3 digits from the right hand side. Check the difference. If the difference is divisible by 7, then the number is divisible by 7. If the difference is divisible by 11, then the number is divisible by 11. If the difference is divisible by 13, then the number is also divisible by 13. If the difference is divisible by 1001, then the number is also divisible by 1001. Okay, so here xyz, meaning from the right hand side, group xyz, the difference is 0. And my dear friends, 7 can divide 0. 7 zeros are 0, 11 zeros are 0, 13 zeros are 0, 1001 zeros are 0, meaning this is divisible by all the numbers 7, 11, 13 and what else? 1001. I will give you one simple example. 1, 2, 3, 1, 2, 3. 3, 4, 5, 3, 4, 5. You check these numbers divisibility by these numbers, and all these numbers can divide these numbers. The reason being, from the right hand side, a group of 3 digits. One part is 123, the other part is also 123. The difference is 0, and all these numbers will divide 0. Therefore, the final answer is 7, 11 and 13. Even if he puts along with this set 1001, that will be correct answer. Okay. So it is not just 7, 11 and 13 as he is mentioning here. It is also 1001. 1001 will also join the same group. This is everything about this problem. This is a problem on divisibility of numbers. Moving on to the next one. Problem number 29. We are doing B series. Okay. How many distinct 8-digit numbers can be formed by rearranging the digits of the number 11, 22, 33, 4 such that odd digits occupy odd places, odd positions, and even digits occupy even positions. Your options are 12, 18, 36 and 72. This is a problem on permutations and combinations. Okay. 1, 1, 2, 2, 3, 3, 4, 4. We are not concerned with the value of the number. We are concerned with only where we are writing these digits, in which positions we are writing. Okay. So, how many distinct 8-digit numbers, right? So, once you change the positions, naturally, the values will get changed. So, how many different numbers, 8-digit numbers we can write? See, these are the 8 digits, and you will have to use all the digits. 8. You will have to fill up all these 8 cells. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So now, which are the positions? Let us check the positions. This is 1, 2, 3, 4, 5, 6, 7, 8. Odd positions. Odd positions are, these are all odd positions. 5, 7. All these are odd positions. Here, you will have to write, you will have to fill up the odd digits only. Which are odd digits with us? 1, 1, 3, 3. These are the 4 odd digits. And we have got 4 places for them. Just fill them. Out of these 4, any of the 4 can come here. And after that, any of the 3. And after that, and means into. And after that, you can fill this box with any of the remaining 2 digits. And after that, and means into. The remaining 1 should be placed here. But there are repetitions. 1, 1, repetitions. 1, 1, twice. 2 times it is repeated, 2 into 1. Then 3 is repeated 2 times, 2 into 1. 2 2s are 4, 4 will get out, 3 2s are 6. This is everything about odd positions and odd digits. Now, let us concentrate on even positions and even digits. Even digits are 2, 2, 4, 4. Again, we have got 4 digits, 4 even digits. And out of them, any of the 4 can come here, and after that, any of the 3, and after that, any of the 2, and after that, remaining 1 should come here. 4, 3, 2, 1, again the same thing. Again, 2 is repeated 2 times. Repetitions all will come down, 2 into 1. 4 is repeated 2 times, 2 into 1. 2, 1, 2, 1 will get cancelled. Otherwise, 2 2s are 4, 4 will get cancelled. 3 2s are 6. So, 6 into 6, the final answer is the third option, 36. 6 into 6, 36. This is very simple problem. In fact, to fill odd digits 1, 1, 3, 3, we have got 4 odd positions. So that can be done in 4, 3, 2, 1 ways. But 1 is repeated 2 times, 3 is repeated 2 times, 2 2s are 4, 4 will get out, 3 2s are 6. Okay. Now you will have to fill up the even places, and again the same thing will repeat. Again you will come across 6. The final answer is 6 into 6, 36 is the final answer. Okay. So similar type, corona. How many different words that can be formed by using all the letters of the word corona? 6 letters are there, start with 6, go till 1. O is repeated 2 times, 2 into 1. 5 4s are 20, 6 3s are 18. The final answer is 360. So all the repetitions will go down, and here we have got repetitions, right? If it is say Mississippi, total 11 letters are there, start with 11, go till 1. M is not repeated, forget it. I is repeated 4 times, 4, 3, 2, 1. S is repeated 4 times, 4, 3, 2, 1. P is repeated 2 times, 2 into 1. Okay. So this is also a problem on the same lines. Moving on to the next problem. A, B, this is a problem on time and work. A, B, C working independently can do a piece of work in 8, 16 and 12 days respectively. A alone works on Monday, B alone works on Tuesday, C alone works on Wednesday. A alone again works on Thursday and so on. Consider the following statements. The work will be finished on Thursday. Statement number 2 says the work will be finished in 10 days. Which of the above statements is or are correct? Your options are 1 only, 2 only, both 1 and 2, neither 1 nor 2. A will finish a piece of work in 8 days. B will finish the same work in 16 days. C alone will finish the same work in 12 days. So first we will have to find LCM and define the work. 8, 16, 12. 4 2s are, 4 4s are, 4 3s are. 2 can divide 4, forget it. 4 3s are 12, 12 4s are 48. 48 is the LCM. So using this LCM 48, let us define the work. How that can be done? If 48 chairs are arranged in a room, the work is finished. This is how we can define the work. Arranging 48 chairs in a room itself is the work. If I ask A to do this work, if I ask A to arrange 48 chairs, he said he needs 8 days time. In 8 days, he will be arranging all the 48. Only goes to say that every day he must arrange 6 chairs because 8 6s are 48, 16 3s are 48, same way 12 4s are 48. These are their individual capacities. These are their individual capacities. A's capacity is to arrange 6 chairs every day. B's capacity is to arrange daily 3 chairs. And C can arrange every day 4 chairs. Now who will come when? A alone works on Monday. A alone works on Monday. A came on Monday. Then B alone works on Tuesday. C alone works on Wednesday. Is it clear? So in these 3 days, 6, 10, 13 chairs got arranged. In the first 3 days, how many chairs got arranged? 13 chairs. Now what happens? C alone works on Wednesday, that is over. A alone again works on Thursday. Next day again A will come. A will come and arrange 6 chairs on Thursday. B, next day Friday, B will come and will arrange 3. C will come on Saturday and will arrange 4. Meaning next 3 days again 13. Next 3 days again 13. So every 3 days, how many chairs are getting arranged? 13 chairs. And when the work will get finished? when all the 48 get arranged. Okay. So every 3 days, 13. 3 days, 13. 3 days, 13. Next 3 days, next 13. Next 1 day, it is 6. So total 10 days, after 10 days, 13 3s are 39 plus 6, 45. See here. After 10 days, only 45 chairs will get arranged. But he is saying the work will be finished in 10 days. No. After 10 days, only 45 chairs will get arranged. When the work will get finished? When all the 48 will get arranged. Therefore, straight away, second is wrong. Now let us check the first one. The work will be finished on Thursday. When the work will get finished? On Thursday. That is, on Thursday, all the 48 should get arranged. Now let's see whether all the 48 will get arranged by Thursday. Again ABC. Saturday, Sunday, Monday, Tuesday. Again 13. 39 are over. Now we want 9 more. Okay. We want 9 more. A will come on Wednesday and will arrange 6 chairs. B will come on Thursday and will arrange 3 chairs. 13, 13, 13, 39, 42, 48. All the 48 are over. When? On Thursday, which is there in the very first statement. The work will be finished on Thursday. That is 100% correct. Okay. So, 3, 6, 9, 10, 11. On 11th day, after 11 days, the work will get finished. In 11 days, the work will get finished. Therefore, second is wrong. First is correct. First option says only one is correct. Okay. This, according to me, is a simple problem, not too complicated. Moving on to the next one. Raju has 10 pairs of red, 9 pairs of white, and 8 pairs of black shoes in a box. If he randomly picks shoes one by one from the box to get a red pair of shoes to wear, what is the maximum number of attempts he has to make? He has got shoes of different colors, but he wants to use red colored ones. And for that, what is the maximum number of attempts he has to make? We are not sure that in the beginning only we will be getting red. If his luck is worse, then he may end up getting white or black shoes in the beginning. So assuming he has got all the 9 pairs white colored shoes in the beginning itself. 9 pairs means 9 twos are 18. All these are white. Assuming his luck is not up to the mark and he got all the 9 pairs of white colored shoes in the beginning itself. Then assuming 8 pairs, 8 into 2, 16 shoes of which color? Black color. Total 8 plus 6. So he has wasted 34 attempts in all before he could see the red ones. And he is asking you maximum, and this is the maximum. After this, he will be forced to get red because in the bag, okay, in the bag, now you are left out with only red colored ones and you will be forced to get them. After this, 35th will be red. 36th will also be red. After 36th attempt, he will have surely at least one pair of red colored shoes. What is the maximum number of attempts he has to make to get a red pair of shoes? That after 35th attempt, he will have only one red. After 36th, he will have two red. And the final answer is the second option, 36. See here, friends, you may your doubt may be, can he not? What if he gives, if he gets, he may get red colored in the beginning itself. Of course, he may get. But he is using the word maximum number of attempts. Okay. So maximum, when he says the word maximum, then first he will have to give chance to the other colored shoes. And one more important thing, if you say you will get red in the beginning itself, then where is the question of going to 27, 46 and all? I mean, the numbers are too big. Okay. So first you give chance to the other colored shoes and then go to red. That will make a sense when you use the word maximum. So this is everything about this problem. Moving on to the next one. Problem number 74, B series. A principal P becomes Q in 1 year when compounded half yearly. Half yearly. Okay, half yearly you make it yearly and you make it 2R. P has become, it is like this. P has become Q in 1 year. Half yearly with R%. Yearly it is 2R%. So 2R%. Next, if it is S%, then yearly it will become Q. Okay. P becomes Q in 1 year when compounded annually with S%. So all these are same. All these are same. Therefore, these two can be compared. 2R% is equal to S%. S is double that of R. S is double of R, meaning S is more. Here S is more. S is more than R. R is less than S. Therefore, the third option C will be correct answer. Your principal amount P will become Q when? If you go with 2R%, if you go with S%. Both are same. So 2R and S need to be equal to each other. S is equal to 2R. S means double of R, meaning S is more, R is less. R is less than S. That is the final answer. This is everything about problem number 74B. Moving on to the next one. How many natural numbers are there which give a remainder of 31 when 1186 is divided by these natural numbers? Your options are 6, 7, 8 and 9. See, every time we want the remainder 31 and the number is 1186. We want the remainder 31. If you want the remainder 31, then the number which is less than 31 should be completely divided. Okay. You should, no remainder. If you don't want any remainder, then let's go for less 31. It will be how much? Here you will get remainder 0, 0. This is the meaning. Okay, here you will get the remainder 0 0. Now double 1 double 5, start with 5, 5 2s are 10, 1, 5 3s are, 5 1s are. Now you can start with 3, 3 7s are, 3 7s. Now you can start with 7, 7 11s are. Meaning all these are the factors. What do you mean factors? Factors meaning these are the numbers that can divide 1155 completely. Okay. And if you take 5 3s are 15. If you take 15, 15 can also divide this number and the remainder will be 0 0, but we want the remainder to be 31. Whenever we divide a number by 15, we will get the remainder less than 15, but we want the remainder to be 31. That is the reason why we must get a number which is more than 31. Only then you can expect the remainder 31. So 5 and 3 will not work out. 5 and 7 will work out. Definitely work out. 35. 5 7s are 5 and 7 combination. 5 and 11 combination 55, no problem. More than 31. Wherever you will come across more than 31, just pick them. So that is the end of 5. Now let's concentrate on 3. 3 into 7 21. No. 3 into 11 33. Yes. Next, 11 into 7 77. No problem. 11 7s are 77, 77 3s are 77 3s are how much? 3 7s are 21, 3 7s are 21 plus 2 231. Yes, no problem. 231 also no problem. What else? 11 3s are 33, 33 5s are these three combination. 11 5 3s are 15, 15 11s are 165. 15 11s are 165. See, these are the numbers which we are searching. These are the numbers which we are searching. By going for different combinations, not only that, they should be more than 31 because the remainder we want is 31. So these are the 6 numbers and the question mark is put on that. How many such numbers are there? There are 6 such numbers. If you divide 1186 by all these numbers, you will be left out with 31. Okay. I will let you know how to get that thing confirmed. 1186 divide it by 35. 35 3s are 35 3s are, yes, we got the remainder 31. You check by using any of these numbers, you will get to see the remainder 31. Therefore, the answer is 6. Okay. You don't get to see any other number other than these, wherein you will get the remainder 31 when you divide this 1186 by these numbers. Okay, you can check other things also afterwards. Okay, now let me go to the next one. What is the sum of all 4-digit numbers less than 2000 formed by the digits 1, 2, 3 and 4 where none of the digits is repeated? Your options are 7098, 8028, 8878, 9238. Less than 2000. can you use 4 and 3 in the beginning? If you use 4, 3 in the beginning, there will be more than 4,000, more than 3,000. Even if you use 2 also, it will be more than 2,000, but we want less than 2,000. Only goes to say that the 1000th place 1 is fixed, undoubtedly. Only then you will get the numbers which are more than 1,000, meaning you can more than 1,000, not more than 2,000 or more than 3,000 or more than 4,000, right? So 1000 place 1 is fixed. Now you are left with only these 3 digits, 2, 3, 4. I can write like this: 1, 2, 3, 4. I've used all the digits, all the 4, and the number is of course less than 2,000. I can write it like this: 1, 2, 4, 3. I can write like this: 1, 3, 2, 4. I can write 1, 3, 4, 2. I can write 1, 4, 2, 3. I can write this as well: 1, 4, 3, 2. And you cannot write any other number which are less than 2,000 using the digits 1, 2, 3, 4. All these are different numbers. All are less than 2,000. All are 4-digit. All are different. And all are found by these 4 digits only. No 2 numbers are same. And this is the exhaust list. And we want the sum of all these, add all these numbers. So, according to my analysis, there are at least 5 to 6 problems only on addition. Okay, that is the reason I have been telling you, you will have to practice to add the numbers. You are supposed to add the numbers correctly and quickly. Otherwise, you are wasting time. 4, 7, 11, 13, 16, 18, 1, 4, 6, 10, 12, 16, 19, 1, 5, 9, 12, 15, 17, 19, 2, 3, 4, 5, 6, 7. Here is the very first option, 7, 9, 9, 8. This is again a problem on, you can take it as a problem on permutations and combinations, permutations, right? Moving on to the next one. What is the number of selections of 10 consecutive things out of 12 things in a circle taken in the clockwise direction? This is the clock. Here is 12. 1, 2, 3. This is how it goes. Okay. And we are picking 10 consecutive things. These are the things. You can start with 1 and go in this direction. So which are the numbers you will pick? Which are the things you will pick? I can pick first, second, third, fourth, fifth, sixth, 7, 8, 9, 10. You can start with 2 also. 2, 3, 4, 5, 6, 7, 8, 9. It will go up to 11. You can start with 3 also. It will go up to 12. You can start with 4 also. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will go up to 1. Meaning you can start with all the numbers. You can start with 1, you can start with 2, you can start with 3, 4, 5. All these are different combinations, and the final answer will be the third option, 12, because there are 12 items, there are 12 things, and for each, from each you can start. Okay, so you will have 12 different selections. This is everything about this problem. Moving on to the next one. For 5 children with ages A less than B less than C less than D less than E, any 2 successive ages differ by 2 years. What is the age of the youngest child? This is the question. So before reading the statement, what you can do here is, okay, without these 2, you just try to solve this problem. Then you will come to know whether we want these informations or not. Okay. So for 5 children with ages A, B, C, D, E, any 2 successive ages differ by 2. Okay. If the first child is X, the age of the first child is X. Next he will be X plus 2 because differ by 2. Difference between any 2 consecutive children is 2. Next child will be X plus 4. Next it will be X plus 6. Next it will be X plus 8. 1, 2, 3, 4, 5. How many children are there? 5 children over. Okay. What is the age of the youngest child? Meaning we want the value of X. We want the value of X. X stands for the age of the youngest. If I use the statement number 2, the average age of the children is 8 years. Add all these, divide by 5, gives you 8. If you shift 5 to the other side, the total will be 40. And if we know the total is 40, then you can find out the value of X. Is it not? X plus 2, X plus 4, X plus 6, X plus 8. 1, 2, 3, 4, 5, X. This is 2, 6, 12, 20. Here you can find out the value of X, which is 4. So I used statement 2 to solve this problem, and I found out the age of the youngest child. Okay. Now, is it possible for me to solve this problem using statement number 1? Statement number 2 is 100% correct. Okay. Using statement number 2, we can manage. Next, now let us check statement number 1. The age of the eldest. Who is the eldest here? X plus 8. He is the eldest. Eldest is 3 times the youngest. Eldest is means is equal to 3 times the youngest. X, 3x, 2x on this side, 8, x is 4. Yes, we got 4. What's the meaning? Statement 1 alone is sufficient. Statement 2 alone is also sufficient. Either of them. Okay. But you are forced to use one of them. Okay. So 1 alone is also sufficient. 2 alone is also sufficient. Of that kind, check which is there in the options. Which one of the following is correct in respect of the above question and statements? The question can be answered by using one of the statements alone. That is correct. One of the statements alone. We can answer this by using one of the statements alone. That is correct. But cannot be answered using the other statement alone. This is wrong. Using the other statement alone also you can answer. That is why it is wrong. You can answer this using first statement alone. And he is saying, but cannot be answered using the other statement alone. That is wrong. First part is correct. Second part is wrong. This is wrong. That is why first is wrong. Moving on to the second option, the question can be answered by using either statement alone. Either statement alone, that is correct. Either of them you can use alone. Okay. So everything is all right with the second option. B should be marked. Moving on to the next one. Z, Z, Y, 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 X, 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 W, 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 W. It goes till A. What is the middle term of the sequence? And the options are H, I, J, M. Z is repeated 2 times. if you start giving the codes in the reverse order, that is A to Z 1 2 3 4, that is usual manner. If I start giving the codes from that end, Z is 1, okay, Z is 1, Y is 2, okay. If I start giving codes like this, Z is 1, Y is 2, X is 3, okay. Here what's happening is Z is not just one time, it is 2 times. Y is not just 2 times, it is 3 times. X is repeated 4 times. This is how it is going. Okay. So Z is supposed to be only 1, but it is repeated 2 times, meaning 1 more. Same way A will become 26, but it is not repeated only 26 times. It will be repeated 27 times in the end. A is repeated in the end 27 times. Okay. So Z is repeated 2 times in the beginning, Y is repeated 3 times, X is repeated 4 times. This is how it goes, and goes till 27, because A is repeated 27 times. Now we are calculating how many terms are there in all, and this is how you can manage like this. And we don't have any formula starting with 2. We have got formula starting with 1. n plus 1 by 2. We have got this formula 1, 2, 3, 4 up to any number. n plus 1 by 2. Assuming 1 is there and we are going till 27. So it will be 27 plus 1 by 2. 2 ones are 2 14s are, right? Now 27 into 14, this is the final calculation. 7 4s are 28, 8, 15, 16, 368, right? $378, but don't forget to subtract 1 because we have added it. So 378 minus 1 is 377. So here we have total number of terms, 377 terms are there in all. Total number of terms are 377, and we want the exact, the one which is there exactly in between. Okay, middle term we want. So middle term on this side 188, on this side 188. The middle term will be 189. Do you agree with me? 188 plus 188 gives you 376 plus 1, which is there in between. So we want 189th term. We want 189th term in this series, right? 189th. 1, 2, 3, 4 up to 19, we will get 190. Okay, this thing you will have to buy it in the beginning itself. Up to 19, 190, easy to remember also. Okay, so if you shift this 1 to this side, it will be 2, 3, 4 up to 19. It is 189. So 19th is 189, and which is 19th. Okay, 27th is A, 26th is B, 25th is C, 24th is D, 24, 23, 22, 21, 20, 19. This is how it goes. A, B, C, D, E, F, G, H, I. So 19th is I, and we want 19th. So everything is all right with the second option. So here the correct answer is B for Bombay. I is the final answer, right? So you will have to by heart some of the things here. It is better you remember some of the results. 1, 2, 3, 4, up to 100, 50, 50, easy to remember. 100 means 50, 50. 1, 2, 3, 4, up to 1000 it is 500, 500. 1, 2, 3, 4, up to 19 it is 190. It is better you remember all these three results, and questions have been asked many a times on this result. And easy to remember, don't use every time this formula. You can avoid using formula. This is the formula to be used, right? To find out the sum of the natural numbers. Thank you for watching this video, and I will be shortly coming with other problems of the same question paper. Thank you. Thank you one and all.